July 29, 1944, 11:23 a.m., 16 miles southwest of Vladivostok, Soviet Far East. The starboard outer engine was dead, trailing black smoke across the pale morning sky. Lieutenant Commander James Hartwell felt the B-29 superfortress shudder as he fought the controls. The yoke vibrating so violently his teeth rattled. They were losing altitude at 200 feet per minute. The Sea of Japan stretched below them like hammered steel, indifferent to whether they made landfall or became another statistics report filed in triplicate back in Washington. "Skipper, we're not going to make it back across the strait." That was co-pilot Martin Chen, his voice tight but steady through the intercom. "Fuel's critical. Number 3 engine temperature is redlining." Hartwell keyed the mic. "Acknowledged. Plot a course for the nearest Soviet airfield. Radio them we're coming in emergency." What he didn't know in that moment, as he nursed 75 tons of crippled aircraft toward foreign soil, was that his forced landing would trigger one of the most audacious reverse engineering programs in aviation history. The decision he was about to make would reshape the balance of power for the next decade. But before we understand how a single damaged bomber became the template for an entire Soviet Air Force, we need to rewind 6 hours to when everything started going wrong. If you're fascinated by the untold stories of aviation history, the moment when engineering meets desperation, hit that like button and subscribe. Because what happened next changed everything about how nations approach military technology, and most people have never heard the full story. The mission had started routinely enough. Hartwell's crew, flying a B-29 nicknamed Tramp after the questionable establishment near their base in the Aleutians, had taken off at 0447 hours for a long-range reconnaissance sweep along the Kuril Islands. The superfortress was the most advanced bomber in the world in 1944, a technological marvel that represented 5 years of American engineering supremacy. Pressurized cabin, remote-controlled gun turrets, a service ceiling of 33,000 feet, 4 Wright R-3350 duplex Cyclone engines, each producing 2,200 horsepower. The aircraft cost $640,000 to build, more than 3 times the price of a B-17, and it carried secrets the War Department valued even higher. "Navigator, give me a position," Hartwell had said into the intercom as they leveled off at 28,000 feet. Lieutenant Sam Okoye's voice crackled back from his station in the nose. "We're 30 miles east of Paramashir, maintaining heading 270, should cross the northern approach vector in 18 minutes. The sky had been clear, visibility unlimited. Below them, the North Pacific rolled in dark swell, occasionally broken by the white wake of a fishing vessel or patrol boat. Hartwell had flown 41 missions. He knew how quickly clear skies could turn deadly. Flight engineer Danny Kowalski, perched at his panel behind the cockpit, monitored the wall of gauges and indicators that made the B-29 possible. Oil pressure, fuel mixture, cylinder head temperature, manifold pressure. Each engine had its own personality, its own quirks that a good engineer learned to read like a poker tell. "Number 4's running a little hot," Kowalski reported. "Nothing critical, but I'm enriching the mixture." "Okay," Hartwell nodded, adjusting trim to compensate for the slight drag. The B-29 was a beautiful aircraft to fly when everything worked, but it was also temperamental. The R-3350 engines were notorious for overheating, for catching fire, for failing at the worst possible moments. The unofficial motto among B-29 crews was simple: if you don't sweat the takeoff, you'll sweat the landing. What they hadn't known was that a Japanese observation post on Paramashir had spotted them on the inbound leg, had radioed to their fighter group at Suribachi. 6 Mitsubishi A-6M fighters, the aircraft Americans called Zeros, had scrambled at 0534 hour. The first indication of trouble came from tail gunner Bobby Yamamoto at 0612. "Bandits! 4 o'clock high, closing fast." Hartwell didn't hesitate. "All gunners, weapons free. Chen, give me full throttle." The B-29 surged forward as Chen pushed the throttles to their stops, the 4 massive engines howling in response. But even at maximum speed, the superfortress could only manage 350 miles per hour, and the Zeros were faster, more maneuverable. "Range 800 yards, Yamamoto called out, his voice steady despite the fact that 6 fighters were diving toward his position. 700, 600. The remote gun turrets were one of the B-29's revolutionary feature. Instead of manually aiming machine guns in cramped positions exposed to slipstream and cold, gunners sat at periscopic sights inside the pressurized cabin, controlling the turrets electrically. It was supposed to be a game changer, but technology, Hartwell had learned, was only as reliable as its weakest component. "Turret 3 malfunction!" That was Waist Gunner Mike Sullivan, frustration clear in his voice. "Fire control system's dead, Skipper. I'm locked out." Hartwell felt his jaw tighten. "Kowalski, can you bypass it?" "Working on it, but..." The first burst of 20 mm cannon fire stitched across the Tramp's right wing, and Hartwell felt the impact through the airframe like a giant's fist pounding sheet metal. The aircraft bucked sideways, and he had to muscle the yoke to bring it level. Taking fire! Taking fire! Yamamoto was shooting now, his quad 50 caliber guns hammering out rounds at 1,200 per minute. Got one! He's smoking! But there were still 5 more, and they were spreading out, setting up for coordinated runs from different angles. This was where the Zero's maneuverability gave them the advantage. They could turn inside the B-29's radius, could position themselves in the blind spots between gun coverage. Another burst, this one from directly ahead. Hartwell saw the tracers flash past the cockpit canopy, heard the metallic ping of rounds punching through aluminum somewhere behind him. Number 3 engine! Kowalski's voice was sharp now. Oil pressure dropping, temperature spiking. I'm shutting it down. Hartwell felt the aircraft yaw to the right as engine number 3's propeller feathered, its blades turning edge-on to reduce drag. 3 engines. They could fly on 3 engines, but their speed would drop, their range would shrink. The Zeros sensed the weakness. They pressed their attack, diving in pairs, their cannon and machine guns tearing chunks from the Tramp's wings and fuselage. Yamamoto was still firing, joined now by top turret gunner Jesse Park and the forward gun positions. The sky around the B-29 filled with tracers, a deadly light show at 28,000 feet. Then came the hit that changed everything. A 20mm round penetrated the number 4 engine cowling and exploded inside the supercharger housing. The engine didn't just fail, it erupted in flame, an orange-red blossom that spread across the wing root with terrifying speed. Fire! Number 4 is on fire! Kowalski was already triggering the engine's fire suppression system, flooding the nacelle with carbon dioxide. Fire bottle deployed, but it's not going out. Hartwell made the calculation instantly. They were too far from friendly territory to make it on 2 engines with a wing on fire. They needed to get this aircraft on the ground before the fire reached the fuel tanks in that wing, before the structural damage caused a catastrophic failure. Chen, plot the nearest landfall. I don't care whose territory it is. We're putting down. Chen's hands flew across his navigation charts. Soviet airfield at Ugolny, about 40 miles northwest. It's our only option. Soviet territory. Neutral in the Pacific War, technically, but Stalin's relationship with the United States was complicated at best. Hartwell knew that landing there meant internment, meant handing over the most advanced bomber in the American arsenal to a nation that had shown considerable interest in obtaining one. But the alternative was burning to death at altitude or drowning in the Sea of Japan. Radio operator, send out an SOS. Tell them we're an American aircraft with battle damage, requesting emergency landing clearance at Ugolny. Radio operator Pete Morrison keyed his transmitter, broadcasting in the clear on international distress frequencies. Mayday, mayday, mayday. This is United States Army Air Force's aircraft Alpha Hotel 79er, requesting emergency landing clearance at Ugolny Airfield. We have battle damage, 1 engine fire, losing altitude. Request immediate assistance. The fire was spreading. Hartwell could see it through the co-pilot's window. Flames licking back along the wing surface, paint bubbling and peeling in the heat. The temperature in the cockpit was rising, sweat running down his face despite the high-altitude cold. Fires through the bottle, Kowalski reported. It's in the wing structure now. They were at 18,000 feet, descending at 400 feet per minute. The 2 remaining engines on the left wing were running at maximum continuous power, but it wasn't enough to maintain altitude. The aircraft felt sluggish, heavy, like a wounded animal limping toward shelter. The Japanese fighters had broken off, either out of ammunition or satisfied that the B-29 was doomed. Hartwell barely noticed. His entire world had narrowed to the gauges in front of him. The feel of the controls, the desperate mathematics of glide ratio versus distance remaining. Soviet tower is responding, Morrison said. They're granting landing clearance. Cleared to land runway 09er, winds light and variable. 14,000 feet, 12,000. The coastline appeared ahead, a dark line against the lighter water. Hartwell had never been so happy to see land. Gear down, he ordered. Chen reached for the landing gear lever, pulled it down. They heard the hydraulic whine, felt the drag increase as 3 massive gear assemblies extended into the slipstream. Gear down and locked, Chen confirmed, checking the indicator lights. 3 green, 8,000 feet. The runway was visible now, a long strip of packed dirt cutting through pine forest. Hartwell could see vehicles moving near the field's perimeter, likely scrambling to respond to the emergency. Flaps 10 degrees. The aircraft shuddered as the wing flaps extended, increasing lift but also drag. They were below 5,000 feet now, the ground rushing up with alarming speed. The fire had consumed most of the number 4 engine and was eating into the wing's internal structure. Hartwell could feel the wing flexing wrong, could sense the aerodynamic imbalance. 300 feet, Chen called out, reading the radar altimeter. 200, 100. The B-29 dropped toward the runway in a barely controlled descent, smoke trailing from the burning engine. Hartwell pulled back on the yoke, flaring to arrest the sink rate, and felt the main gear kiss the dirt with a heavy thump. They bounced once, came down again harder. Hartwell stood on the brakes, feeling the aircraft shudder and shake as it decelerated. The nose gear touched down, and they were rolling, slowing, the end of the runway approaching fast. 50 miles per hour, 40, 30. The ramp Tramp lurched to a stop with 200 feet of runway remaining. "Shutdown checklist," Hartwell said, his voice surprisingly calm. "Kowalski, hit the master fuel cutoff. Everyone out now." The crew didn't need to be told twice. They popped hatches and tumbled out onto foreign soil, running clear of the aircraft as Soviet fire trucks raced toward the burning bomber. Hartwell was the last one out, dropping from the forward hatch and jogging away from the ramp Tramp as foam began covering the... He turned to look at his aircraft, at the technological marvel that had just become an intelligence goldmine for the Soviet Union. That's when he saw the men approaching, not just Soviet airfield personnel, but officers in the dark green uniforms of the Red Army Air Force, and behind them, civilians in plain clothes who walked with the particular purposefulness of intelligence operatives. What Hartwell didn't realize was that several of those men had been waiting months for exactly this opportunity. They carried notebooks, cameras, measuring equipment. Within hours, they would begin the most comprehensive examination of foreign military technology ever attempted. The officer in charge, a colonel whose shoulder boards bore the insignia of an engineering directorate, stopped in front of Hartwell and spoke in accented but clear, "You and your crew are now guests of the Soviet Union. You will be well treated, but you will not be leaving soon." He gestured toward the ramp Tramp, where teams were already beginning to swarm over the aircraft. "Your machine, however, will be staying permanently." Hartwell wanted to object, to cite international law, to demand repatriation, but he was in no position to demand anything. He just handed over the crown jewel of American strategic aviation to a nation that would very much like to build its own. Within 24 hours, the ramp Tramp was disassembled into major components and loaded onto rail cars bound for Moscow. Within a week, the crew was transferred to an internment facility near Tashkent, comfortable but heavily guarded. They would remain there for 8 months before being quietly repatriated through Iran. But the story of the ramp Tramp was just beginning. 900 miles to the west, in a secure facility outside Moscow, a team of engineers gathered in a cavernous hangar. At its center sat the B-29, partially reassembled, surrounded by scaffolding and measurement equipment. Chief designer Andrei Volkov stood on a platform level with the aircraft's cockpit, examining the instrument panel with the intensity of a surgeon studying an X-ray. At 47, Volkov had spent 20 years designing military aircraft for the Soviet Union. He'd created fighters, attack planes, even experimental prototypes that never left the drawing board, but he'd never seen anything like this. "Comrade Volkov, the preliminary assessment is complete." That was his deputy, Boris Petrov, climbing the scaffolding with a thick folder of documentation. "The results are extraordinary." Volkov took the folder, flipping through page after page of technical specifications, performance data, construction details. Each page represented hours of meticulous measurement, analysis, reverse calculation. The B-29's service ceiling was 3,000 meters higher than any Soviet bomber. Its range was double. Its defensive armament was controlled by a fire control computer that integrated radar, ballistics, and hydraulics in ways Soviet designers had never attempted. "The pressurization system alone," Petrov said, shaking his head. "We have nothing comparable. The entire crew compartment maintains sea-level pressure up to 8,000 meters. Volkov nodded slowly, his mind already racing through the implications. "What about the engines?" Wright R-3350 duplex Cyclone, 18-cylinder twin-row radials, each producing 2,200 horsepower. They use a 2-stage supercharger, direct fuel injection, and a cooling system that's far more efficient than anything in our inventory. "Can we manufacture them?" Petrov hesitated. "Comrade Chief Designer, we can barely measure them accurately. The tolerances are extraordinary. The crankshaft alone is machined to within 0.05 of a millimeter. Our factories can't consistently achieve that precision." But Volkov was already thinking past the obstacles. In the Soviet system, can't was a word that ended careers. Impossible was a confession of weakness. If the leadership wanted a Soviet B-29, then a Soviet B-29 would be built. What he didn't know yet was that the order had already come down from the highest levels. Stalin himself had seen the preliminary reports and made a decision that would consume billions of rubles and employ tens of thousands of workers. The Soviet Union would not just study the B-29, they would copy it exactly. 3 days later, Volkov was summoned to a meeting in the Kremlin. He arrived at the appointed time, was escorted through corridors heavy with history and menace, and finally shown into a conference room where a dozen senior officials waited. The man at the head of the table was someone Volkov recognized immediately: Vyacheslav Molotov, People's Commissar for Foreign Affairs and one of Stalin's closest advisors. "Comrade Volkov," Molotov said without preamble, "you have examined the American bomber." It wasn't a question. "Yes, Comrade Commissar. It's the most advanced aircraft I've ever encountered. How long to build a Soviet version?" Here was the moment that would define Volkov's career, and possibly his life. He could give a realistic estimate: 5 years, maybe 7, accounting for development time, tooling, testing. Or he could give the answer the leadership wanted to hear: 2 years for the first prototype, Volkov heard himself say. 4 years for full production. Molotov's expression didn't change. "You understand that the motherland needs this capability. The Americans have a weapon that can strike targets we cannot reach. This imbalance must be corrected." "I understand, Comrade Commissar." "Then you also understand that failure is not acceptable. You will have whatever resources you require. Every factory, every research institute, every skilled worker in the Soviet Union is at your disposal. But in return, you will deliver what you have promised." The unspoken threat hung in the air. Deliver or face consequences that didn't bear thinking about. Volkov nodded. "We will deliver." What followed was an industrial mobilization unlike anything in peacetime history. Entire factories were retooled to produce B-29 components. Research institutes were redirected to study specific systems. Universities were ordered to graduate engineers with specializations in areas that Soviet aviation had barely explored. But the first challenge was more fundamental. How do you copy something this complex? Back at the secure facility, Volkov's team faced a daunting reality. The B-29 contained approximately 15,000 unique parts. Every part needed to be measured, documented, reproduced. Every dimension, every material specification, every manufacturing process had to be determined through examination alone, because the Americans certainly weren't going to provide blueprints. "We'll divide the aircraft into sections," Volkov announced to his assembled team on the first day of the full program. "Fuselage, wings, empennage, power plant, systems. Each section gets a dedicated team. Your task is complete documentation. Measurements accurate to within 1/10 of a millimeter, material analysis, assembly procedures, everything." Senior engineer Nikolai Sokolov raised his hand. "Comrade Chief Designer, what about items we cannot duplicate exactly? The rubber formulations, the aluminum alloys, the electrical components? Find the closest Soviet equivalent." "But," Volkov's voice hardened, "where it affects performance, we develop new capabilities. If Soviet industry cannot produce the materials we need, then Soviet industry will be upgraded." They started with the fuselage. Teams of engineers swarmed over the ramp Tramp, armed with calipers, micrometers, coordinate measuring machines. Every frame, every stringer, every skin panel was measured and recorded. But measurements alone weren't enough. They needed to understand why the B-29 was built the way it was, needed to grasp the engineering logic behind each decision. Engineer Maria Volkova, one of the few women on the team and a specialist in structural analysis, spent 3 days studying a single fuselage joint where 2 sections came together. She measured the rivet spacing, the plate thickness, the overlap distance. She calculated the load distribution, the stress concentration, the fatigue life. "This joint is optimized for weight and strength," she explained to Volkov during a review session. "The Americans use a specific rivet pattern that distributes loads more evenly than our standard approach, and the overlap distance is exactly calculated to prevent crack propagation. Can we duplicate it? Yes, but our rivet guns need modification to achieve the precise spacing, and we'll need to train workers on the new patterns. Multiply that challenge by thousands of similar components, and the scale of the task became clear. This wasn't just copying a design, it was copying an entire manufacturing philosophy, an approach to engineering that differed fundamentally from Soviet practices. The engines presented an even greater challenge. Vladimir Dobrinin, the Soviet Union's leading aircraft engine designer, stood in front of a disassembled R-3350 engine and felt something close to despair. The complexity was staggering. The precision required was beyond current Soviet capabilities. "The crankshaft," he explained to Volkov, "is machined from a single forging of high-strength steel. The bearing journals are ground to tolerances we can barely measure, let alone achieve in mass production. And that's just one component." Volkov examined the massive crankshaft, its polished surfaces gleaming under the workshop lights. "What if we can't match the precision? Then the engines will fail, perhaps immediately, perhaps after a few hours of operation, but they will fail." It was a defining moment. The Soviet Union could build engines that were rugged, reliable, simple to manufacture and maintain, but engines that were both powerful and precise? That combined high performance with high reliability? That was new territory. Then we upgrade our capabilities, Volkov said quietly. Talk to the machine tool institutes. Tell them what precision we need, and tell them they have 6 months to deliver the equipment to achieve it. Over the following months, the program expanded in ways that touched every corner of Soviet industry. New machine tools were designed and built. Metallurgists developed aluminum alloys that matched the American specifications. Chemical engineers formulated hydraulic fluids, lubricants, rubber compounds. The instruments presented their own unique challenge. The B-29's cockpit contained dozens of gauges, indicators, and controls that Soviet factories had never produced. Each one needed to be replicated. Yuri Markov, tasked with duplicating the engine instruments, stared at an American fuel flow gauge and wondered how he was supposed to copy something he barely understood. It's not just measuring fuel flow, his assistant explained. It's compensating for temperature, pressure, and density variations. The mechanism inside is incredibly sophisticated. Markov carefully disassembled the gauge, photographing each step, measuring each component. The hairspring that provided the restoring force was made from an alloy they couldn't identify. The jewel bearings were ground to optical precision. The scale markings were applied using a process Soviet instrument makers didn't have. He worked for 2 weeks before producing a functional copy. It wasn't exact. The Soviet version was slightly less accurate, slightly less reliable, but it worked well enough. Well enough became the unofficial motto. Perfect duplication was impossible, but functional equivalence was achievable. By the end of the first year, they had complete documentation of the B-29. Thousands of technical drawings filled secure archives. Material specifications covered hundreds of pages. Manufacturing procedures were developed for every component. But documentation wasn't the same as production. Actually building the aircraft required transforming Soviet industry. Factory number 22 in Kazan had been producing medium bombers since before the war. Now it was retooled for the B-29 copy, designated the Tu-4 in Soviet nomenclature. Plant director Georgy Kiselev stood on the factory floor and watched as the first fuselage section were assembled. Where before they'd built aircraft using relatively simple construction, now they were working to tolerances that would have been considered unnecessary, even wasteful, by traditional Soviet standards. Comrade Director, we have a problem. That was shift foreman Ivan Petrov, holding a clipboard thick with inspection reports. 20% of the skin panels are being rejected for not meeting dimensional tolerances. Kiselev felt his stomach tighten. 20% rejection rate meant delays, meant waste, meant he'd have to explain to Moscow why production was behind schedule. Why are they failing? The workers aren't used to the precision required. They're rushing, trying to meet quotas using the old methods. But the Tu-4 doesn't forgive mistakes. Here was the fundamental tension. Soviet industry excelled at mass production, at churning out equipment in vast quantities even if individual quality varied. But the B-29 represented a different philosophy. Lower quantities, higher precision, unforgiving specifications. Slow down the line, Kiselev ordered. Increase inspection intervals, and anyone who produces 3 rejected panels is reassigned to training for a week. The decision would put them further behind schedule, but there was no alternative. A Tu-4 built to inadequate standards would kill its crew, and dead air crews didn't advance production goals. Similar scenes played out at factories across the Soviet Union. Metalworks struggled to produce aluminum sheets of consistent quality. Electronics plants tried to match the performance of American radios and radar sets. Even seemingly simple items like wiring harnesses became challenges when specifications demanded exact lengths, precise routing, and specific connector types. But slowly, painfully, Soviet industry adapted. By early 1946, the first Tu-4 prototype was taking shape in Kazan. Volkov traveled there to inspect progress, walking along the assembly line and examining each station. The aircraft looked like a B-29 because it was a B-29, copied down to the smallest detail. Even items that seemed unnecessary were included. There was a story, possibly apocryphal, that early Tu-4s included a patch covering a bullet hole in the original ramp Tramp because the Soviet technicians assumed it must serve some aerodynamic purpose. Whether true or not, the story captured the approach. When in doubt, copy exactly. When will it be ready for flight testing? Volkov asked Kiselev. 3 weeks if all goes well. We're waiting on the final engine deliveries. The engines remain the most challenging component. Dobrynin's team had created a Soviet version of the R-3350, designated the AH-73TK. It used many of the same design principles, but with Soviet materials and manufacturing. The first engine tests had been discouraging. 2 engines had failed catastrophically in 10 hours of running, but modifications and improvements gradually increased reliability. May 19, 1946, 6:34 Kazan Airfield. Test pilot Mikhail Gromov walked around the first Tu-4 prototype, conducting his pre-flight inspection with the methodical care of someone who knew his life depended on finding problems before they became airborne. At 52, Gromov was one of the Soviet Union's most experienced pilots. He'd set distance records before the war, flown combat missions during it, and now faced perhaps his greatest challenge, proving that Soviet industry could match American capabilities. "All systems show green," his co-pilot reported from inside the aircraft. "Fuel load is full. Engines have completed warm-up cycle." Gromov climbed into the cockpit and settled into the left seat. The interior was uncannily familiar. He'd studied captured manuals, had even examined the Tramp personally, but knowing an aircraft intellectually was different from trusting it with your life. "Tower, this is Test 01, requesting taxi clearance." 01, you are cleared to taxi runway 27. The four AH-73TK engines rumbled to life, their deep throb shaking the airframe. Gromov released the brakes and felt the massive bomber begin to roll. At the runway threshold, he ran through the final checklist. Magnetos, fuel mixture, propeller pitch, flaps, trim. Everything by the book, because the book was written in American blood and Soviet ambition. 01, you are cleared for takeoff. Gromov pushed the throttles forward, feeling 66,000 pounds of aircraft accelerate down the concrete. The tail came up at 70 miles per hour. At 110, he eased back on the yoke and felt the wheels leave the ground. The Tu-4 climbed into the morning sky, and Gromov allowed himself a small smile. It flew against all the doubts, all the challenges, all the supposedly impossible obstacles. It flew, but first flights were just the beginning. Over the following months, the prototype underwent extensive testing. Engineers discovered problems with the electrical system, with the hydraulics, with the bomb bay doors. Each problem was identified, analyzed, solved. By late 1946, 3 prototypes were flying. By early 1947, production aircraft were rolling off assembly lines in Kazan, and 2 other factories had been equipped to join production. The production target was audacious: 850 aircraft in 4 years. It would require mobilizing resources on a scale usually reserved for wartime, but Stalin had made clear that nuclear parity with the United States was a national priority, and the Tu-4 was the delivery system that made parity possible. Factory managers worked 18-hour days. Workers were recruited from across the Soviet Union and trained in the specialized skills required. Supply chains were established for thousands of components. The pressure was relentless. Volkov, now leading the overall program, received weekly reports on production rates, quality metrics, testing results. Any deviation from plan triggered immediate investigations. "We delivered 42 aircraft last month," a production coordinator reported during one status meeting. "The plan called for 45. Why the shortfall?" Volkov asked, his voice dangerous calm. "Engine delivery delays from factory number 19. They're struggling to maintain quality standards at the required production rate." Volkov made a note. Factory number 19 would receive additional technical support, additional resources, and if that didn't solve the problem, a new management team. This was how the Soviet system worked when it focused its full weight on a goal: relentless pressure, unlimited resources, severe consequences for failure. It was inefficient, sometimes brutal, but it produced results. By 1948, Tu-4 bombers were entering service with Soviet strategic aviation units. Aircrews trained on the new aircraft, learning systems far more complex than anything they'd flown before. Colonel Viktor Novikov, assigned to command the 1st Operational Tu-4 Regiment, stood in front of his assembled aircrews and briefed them on their new mount. "The Tu-4 is not a forgiving aircraft," he said bluntly. "It demands precision, discipline, and constant attention. But in return, it gives you capabilities no Soviet aircraft has ever possessed. You can fly higher, farther, and carry larger weapons than ever before." The aircrews listened, with a mixture of excitement and apprehension. The Tu-4 represented a fundamental shift in how the Soviet Union projected power. No longer limited to regional operations, they could now threaten targets across Europe, across Asia, potentially even across the ocean. Training accidents were inevitable. The complex systems, the demanding flight characteristics, the sheer size of the aircraft all contributed to a learning curve measured in crashed aircraft and dead crews. But gradually, Soviet aircrews mastered the Tu-4. Flight procedures were refined. Maintenance practices were established. The strategic bomber force grew from a single regiment to multiple divisions. By 1949, when the Soviet Union detonated its first atomic bomb, the Tu-4 fleet numbered over 300 aircraft. The weapon and its delivery system had been developed in parallel, each enabling the other, together creating a strategic capability that changed the global balance of power. But what about the Tramp's original crew? 8 months after their forced landing, Hartwell and his men were moved from their internment facility in Tashkent to a location near the Iranian border. No explanation was given, but they understood what was happening when they were provided with civilian clothes and new identification papers. "You are being repatriated through neutral territory," their Soviet liaison explained. "You will be transported to the Iranian border, where you will cross on foot. From there, you will make your way to Tehran and contact the American embassy." It was all very civilized, very carefully orchestrated to maintain plausible deniability. The Soviet Union had never officially acknowledged holding American airmen. The Americans had never officially protested their detention. As Hartwell crossed into Iran on a cold November morning, he looked back at Soviet territory one last time and wondered what had happened to his aircraft. He'd heard rumors from guards, whispers about a massive program to copy the B-29, but he dismissed them as propaganda or exaggeration. How could the Soviets possibly duplicate the most advanced bomber in the world? They lacked the industrial base, the technical expertise, the precision manufacturing capabilities. It would take them decades if they could do it at all. He had no way of knowing that at that exact moment, the 200th Tu-4 was being completed in Kazan, that Soviet engineers had not only copied his aircraft, but had established an entire production infrastructure around it. The intelligence reports that greeted him in Tehran were shocking. Photographs taken by reconnaissance aircraft showed formations of what looked like B-29s flying over Soviet territory. Defector reports described massive production programs, entire factories dedicated to copying American technology. "They actually did it," Hartwell said softly, looking at the grainy photographs. "They copied the whole damned aircraft." His co-pilot, Chen, stood beside him and shook his head in disbelief. "How?" "The tolerances alone should have been impossible for their industry. Never underestimate what desperate people can achieve when failure isn't an option," Hartwell replied. The Tu-4 program became one of the most successful reverse engineering efforts in history. By the time production ended in 1952, the Soviet Union had built 847 aircraft, each one a testament to industrial determination and engineering skill. But success came at a cost that statistics couldn't capture. Thousands of workers had labored under brutal pressure. Factory managers had faced impossible demands. Engineers had been pushed to their limits and beyond. Volkov, the chief designer who had promised to deliver the impossible, received the Stalin Prize for his work. He stood on a stage in Moscow, accepting congratulations from leaders who had once threatened him with consequences for failure. In his acceptance speech, he spoke carefully, saying all the right things about Soviet ingenuity and socialist superiority. But later, in private, he allowed himself a moment of honest reflection. "We copied an American aircraft," he told his deputy, Petrov. "We did it brilliantly, but we still copied. When will we be able to create something original that others want to copy?" It was a question that would haunt Soviet aviation for decades. The Tu-4 proved that the Soviet Union could match Western technology through sheer effort and determination. But it also revealed a deeper weakness. The industrial system excelled at mobilizing resources for specific goals, but struggled with the kind of sustained innovation that produced aircraft like the B-29 in the first place. American engineers who later examined captured Tu-4s were impressed by the quality of the copying, but noted numerous subtle differences that revealed the challenges Soviet industry had faced. Different materials, slightly different dimensions, simplified systems where exact duplication proved impossible. "It's remarkable work," one American engineer wrote in his assessment. "They solved problems we would have considered insurmountable, but in doing so, they created an aircraft that's slightly different in 1,000 small ways. It's a Tu-4, not a B-29, and the differences matter." Those differences did matter, particularly in long-term reliability and maintenance. The Tu-4 required more frequent engine overhauls, more intensive maintenance, more spare parts. Soviet aircrews joked darkly that the aircraft's unofficial motto was, "If it's not broken, it will be soon." But for all its limitations, the Tu-4 served its purpose. It gave the Soviet Union a credible strategic bomber force at a critical moment in history. It enabled the nuclear deterrent that shaped Cold War strategy for the next 4 decades. And it all started with a single damaged B-29, making an emergency landing on a summer morning in 1944. The Tramp itself was eventually put on display in a Soviet aviation museum, a trophy of sorts, though the label carefully avoided mentioning exactly how the aircraft had been acquired. Visitors would walk past it without knowing its full story, without understanding that this one aircraft had triggered an industrial mobilization that employed hundreds of thousands of workers and produced nearly 1,000 bombers. Hartwell never saw the Tramp again. He returned to the United States, was debriefed extensively by intelligence officers who wanted to know every detail of his time in Soviet custody, and eventually retired from the Air Force with the rank of colonel. In his retirement, He occasionally gave lectures on his wartime experiences. When asked about the forced landing and the subsequent Soviet copying program, he would smile wryly and say, "I made the only decision I could make to save my crew. The fact that it also handed over our most advanced bomber to the Soviets? That still keeps me up some nights." The question of whether Hartwell made the right decision continues to be debated by military historians. Should he have tried to ditch in the ocean, destroying the aircraft but likely killing his crew? Should he have attempted to reach American-controlled territory, even knowing the aircraft probably wouldn't make it? There are no easy answers. In the moment, with a wing on fire and altitude bleeding away, Hartwell chose to save his crew. That they all survived and eventually returned home justified his choice, regardless of the strategic consequences. The broader lesson of the Tu-4 program is more complex. It demonstrated that determined reverse engineering could overcome seemingly impossible obstacles. It proved that the Soviet industrial system, for all its inefficiencies, could mobilize on a scale that Western nations found difficult to match. But it also revealed the limits of copying. The Tu-4 was obsolete almost from the moment it entered service, already being superseded by new American designs that took aviation in different directions. Soviet engineers had spent 4 years and enormous resources duplicating a design that represented 1943 American thinking, and by 1949, the Americans were flying jet bombers that made the whole piston-engine strategic bomber concept outdated. This reality drove Soviet aviation in new directions. Instead of copying the next generation of American bombers, Soviet designers like Andrei Tupolev, whose design bureau built the Tu-4, moved toward original designs. The Tu-16, Tu-22, and eventually the Tu-95 represented indigenous Soviet approaches to strategic aviation, each with its own strengths and weaknesses. The age of simple copying was over. The Tu-4 had served its purpose, filling a critical gap in Soviet capabilities at a crucial moment in history. But it was a bridge, not a destination. Today, a few Tu-4s survive in museums, massive aluminum relics of a particular moment when technology, espionage, and industrial determination intersected. They stand as monuments to both American engineering excellence and Soviet industrial might, to the aircraft that started a revolution and the nation that copied it with obsessive precision. Engineers and historians who examine these survivors can trace the story in the details. Here, a slightly different rivet pattern, where Soviet practices differed from American. There, a simplified electrical connector that proved easier to manufacture in quantity. Everywhere, the evidence of an industry pushed to its absolute limits and somehow succeeding. The Tramp's emergency landing lasted less than 5 minutes from the moment Hartwell saw the runway until the aircraft stopped rolling. But the consequences of those 5 minutes rippled through history for decades, shaping the Cold War, influencing nuclear strategy, and demonstrating what could be achieved when a nation focused its full resources on a single goal. For Hartwell, watching from his retirement home in California as news reports described Soviet strategic bombers flying over Red Square in military parades, the irony was impossible to miss. His split-second decision to save his crew had inadvertently provided the template for those parades, had enabled the very military capability American planners most feared, but he never regretted his choice. "I was a pilot, not a strategist," he said in one of his final interviews, given when he was in his 80s. "My job was to bring my crew home alive. I did that. What happened afterward was beyond my control and beyond my responsibility." Ciao. Perhaps that's the truest lesson of the Tramp story. History turns on individual decisions made in moments of crisis, but those making the decisions rarely understand the full scope of consequences that will follow. Hartwell chose survival over strategy, humanity over hardware. The Soviet Union chose ambition over impossibility, industrial mobilization over realistic assessment of capabilities. And somewhere in the intersection of those choices, the Tu-4 was born, an aircraft that should never have existed, built by an industry that shouldn't have been able to build it, succeeding through sheer stubborn refusal to accept the word impossible. 847 times, Soviet workers proved that impossible was just another word for difficult. 847 times, they turned American aluminum and Soviet determination into an aircraft that changed history. And it all started with a damaged bomber, a desperate crew, and an emergency landing that no one involved would ever forget.